So, I want to show you, maybe I have too many slides, but I will try to be short. The main results we got in the past year about two new PRS associated with two positive bars and their implication for the nebular model.
Oh, that's recording your voice. That doesn't control your slides at all.
Okay. So far, if we focus on repeating positive bars, we have a census of almost 60 objects. And there is an interesting link between repeating and repeating positive bars by a recent paper. So maybe what we find with these objects can be generalized later to more significant statistics. Anyway, 4 repeating positive bars have been associated with a PRS, a compact radio source. And we have also more candidates, these 3, 2 by Piquetal, I would like to follow up, maybe, with higher resolution, plus 1 from the recent work by the China collaboration. Many more will come in the future with other facilities, but let's try to concentrate on what we have right now. I will show you the first result we got about this PRS. That is the one paired to FRB 24A. We started observation as soon as we got a first indication of a persistent radio source in that region, but BLA was not the right configuration to get high resolution observation. So what we observed at the beginning was a diffuse extended region that was emitting at 22 gigahertz. That was not detected with the DLDI, so both Emerlin and UVN observation were not detected. So we were convinced that maybe there was no compact emission associated with the FRB, and the first paper was indeed some consideration about the location of the facility bars in a larger star-forming region and possible implication for the progenitors. Later, some more interesting paper came with Keck observation of the host, where you can see the position of the FRB here, plus another background AGN here, and confirming that it was a star-forming galaxy. More radio observation with the BLA in extended configuration at lower frequency with respect to our observations revealed that the entire bar of the host was emitting, so star-forming activity all along these regions, with some more enhanced emission in correspondence of the FRB and the center of the host. So we follow up with more observation at higher resolution, higher frequency, and we could spot with a resolution of half an arcsecond this region that was consistent with the EVM position of the facility bars. At 22 gigahertz, we still got a detection, but at lower significance, and it is the red contours you can see here. Black contours are 15, and colors are the 6 gigahertz image from a Donde tablet I showed you in the slide. So we also conducted a millimeter observation because it is important to exclude that the spot we were seeing was the star-forming region, and we got some upper limit with NOEMA at 20-30 gigahertz, showing that the star-forming rate should be below 2.2 solar masses per year. Also, optical observation with GTC revealed that the star-forming rate at that location should be about 0.1. So everything was indicating that the radio emission that we were seeing that was compact on the BLA resolution should be due to something else. What can it be? There were these 2 interesting papers by Yang et al. Discussing the implication for a nebular model. So we tried to put these objects on the expected relation, and thanks to this low luminosity in radio and low rotation measure, we could expand, as you have seen in the previous talk, the range, the explored range by 2 order of magnitudes, confirming the trend that we were seeing. So the puzzling thing is the SED, because as you see in the radio, you have an inverted spectrum that is unlike the other 2 known so far. So we expect to see a peak somewhere here, but you really need sensitive observation in the millimeter that we could not get approved, unfortunately. So we could not test this scenario yet. We hope to do that in the future. And one last consideration is that we have, anyway, high resolution observation scheduled for this spring with VLA plus FRB plus VLA, that is the high sensitivity array that is able to give you the sensitivity to spot the compact emission associated with the expected PRS that you see here. So we will definitely test more of these objects in the near future. So the emission we see until now is still consistent with both main scenarios expected for the nebula emission, that is the magnetar, but also the apparacratic FRB. And last, I would like to show you the new PRS that we spot with the fast reading bus that was discussed in the previous talk. I don't need to reintroduce everything again. We perform VLDA high resolution observation in September, just after the attempt from these two different groups that were identifying a consistent compact continuous emission associated with this FRB. So we could observe with a DDT, so only one frequency, but we could put a point here and build the SED that of course, here we use data different resolution. So I will rely more on the results from the previous speaker about consistently reconstructing the SED. But here there was already an indication of a peak that is nevertheless still consistent with a power law within errors. So you cannot be sure 100%. But the main thing was that the emission is compact on the Parse scale, and we can clearly detect it, and this is the only 5 sigma peak in the entire uncertainty region of the precise collaboration location of the FRB. So we are pretty sure this is the only counterpart of that FRB. So we could add another point to our relation. So now we have 4 points, and they all stay on the expected relation. Plus, you can see here the two green square are the candidates from a Ipik et al. Paper. So if confirmed, they will nicely support again this relation. Plus, I would like to stress that the resolution is of course important, because here you can see this is the beam of GMRT in orange. In red you can see the beam of Meerkat. So they both include the entire host galaxy that you can see in the optical observation here. These are optical observations from LBT that we perform for this work. So going down to very high resolution is important to exclude the possible contribution of the host and start forming regions like the ones we were seeing before. So thanks to this optical observation, we could also confirm that this is a star-forming galaxy in the BPT diagram. You can see the position here. And the other 3 points are the position of the 3 known host galaxy of a PRS. So to conclude, we have now 4 PRS, and they seem to nicely lie on the expected relation for the nebular model. We need, of course, both sensitivity and resolution to spot them and to disentangle their emission from the possible contribution of the host. And of course, we will be able to fill that plane with more objects spotted with future generation instruments. So, looking forward to the next VLBI observation, and thank you very much.
Great. So you've actually kept under time, which is great. So we have time for discussion and questions. Yes.
Hi. Yeah, so I was wondering about the spectrum for the 24 or whatever. Yeah, so how do you interpret that? It's not really consistent with supertone self-absorption. What do you make of this?
Yeah, you say it's not consistent because it would be too young.
Well, it's too shallow for supertone self-absorption, right?
Yeah, we are not certain about that. What we know is that probably if you observe that at even higher resolution, you are able to get rid of some possible contribution from yours. Because we know that it is compact in the VLA beam, but it lays upon a layer of diffuse emission. So we try to subtract that to have the real emission from that component. But still, if there is a contribution, it could be that it goes down about here. So I think about 20-30 gigahertz could still be a possible peak location, and still possibly still consistent with synchrotron self-absorption. What do you think?
Well,
It's very difficult.
the peak location is one thing. I'm more worried about the slope, the spectral slope. Yeah. So I'm still not sure how you explain that.
Yeah.
I think in your paper you mentioned that it becomes self-absorbed when its value is less than minus 0 point something.
Yeah, probably. What you expect is a slope of 2.5.
Yeah, but it's higher than that, right?
Yeah, it's higher than that, but within errors, maybe you can see. Yes, I not a clear answer, but we'll see with more observation. What we want to do is, we just seen some ALMA archival data here, 130. They show a detection here, but the beam is too large, so it includes also self-forming negativity. We want to repeat those observations at higher resolution and finally go slow. And plus, with higher resolution observation, we are going to observe at 15 gigahertz. It's about here, yeah. So if the flux is lower, maybe we can also exclude and get rid of some bias in the flux. We'll see.
We have any?
Oh,
No, we're not.
it's already asked.
Polarization of PRSs.
And in this case, it's too faint to continue polarization because it would be a few percent of the flux, probably. So we don't have enough signal to noise to study that.
Go ahead, we still
Yeah.
have.
Yeah, so what's the maximum new M value that your pulsar-wind nebula model can accommodate and
Maximum
explain?
polarization.
New M, so maximum peak of the synchrotron spectrum, where the model still is self-consistent with the observations.
I think it can go up to 10-20 years or less.
So means you
For
expect.
this one, you mean? For
Yeah.
this one. We didn't try to fit actually synchrotron self-absorbed component yet, because you cannot constrain that with enough points. So
I'm wondering that if you fit the pulsar-wind nebula model, there are constraints on the age as well as new M, and then you can come up with a phase space that is permissible. So I was just wondering about that.
yeah, I don't know the
We can chat.
yeah, we can just.
One final question or comment from
Yeah,
me.
just comment to most of it and band. So these nebula, they are not like simple synchrotron, also in nebula models, because we have FRBs continuously injected, they're heavily refreshed, and reinjection, and there are some low frequency FRBs probably absorbed and heat up. So the modeling actually was done by Gabriele back in 2016. So the spectrum is quite complicated. You don't really clearly see if you have Nebulae or self-absorbed slopes. For this specific case, we didn't model. I'm just saying that there could be probably a regime that you can have these kind of slopes. And, yeah, so it's not like very simple. You can say very great case.
In nature, there are multi-zone units. In one zone, synchrotron self-absorption. You can just play around with it, but that's not affecting the